Okay, folks, we are back and we're looking at graphing quadratic functions. Second part. Now, last time we learned about translating or moving y equals x squared around to different parts of the coordinate plane. Just a real quick review. If I have something that looks like this, y equals x minus 3 quantity squared plus 1, remember that we take the very basic y equals x squared shape, this parabola that's smiley looking up, and remember that this means move right 3, and this means move up 1. So we're going to go ahead and move right 3 up 1, and from there we draw our basic parabola, y equals x squared. Okay? Now, if we had the same thing, except that it was, say, y equals, well, let me do a new color. Let's go blue. Okay. If we had y equals negative quantity x minus 3 squared plus 1, again, the vertex is still 3, 1. So it's going to be 3, 1. It's going to be in the same spot, but now it's negative. This means it's going to be frowning. Okay? So instead of over 1, up 1, it's going to be over 1, down 1, over 2, down 4, 1, 2, 3, 4, over 3, down 9. So that's going to be right there. And then across our axis of symmetry, it goes like that. Right? So the negative makes it what I call frowny. It opens downward. Okay? So that's pretty straightforward. Okay? So you can think of it as the negative in front of the x squared part, okay, reflects it. It reflects it in this case, like as if this were a mirror here, and this now is pointing the other direction. Okay? So that's having to do with reflection. So now we're going to be talking about roots. That's going to be the bulk of what we're talking about. Okay, you know what? Before we move on to roots, how about if you practice one real quickly? Go ahead and see if you can graph this right here. Let's go with y equals negative x plus 5 quantity squared minus 3. Go ahead and pause and see if you can graph that on a coordinate plane. Okay, pause the video now. Okay, you should be back. Remember, this means it's, of course, frowny, and the vertex is the opposite of the squared part. So the vertex is negative 5, and then this part, negative 3. So we go negative 5, negative 3, just right there. Okay? And your graph should look like that. Okay? So let's move on to talking about roots. Now, if we have an equation that looks like this, say y equals a quantity x minus 2 and then x plus 4. Now in the past you could have looked at these two binomials, multiply it out, and that's cool. But right now we actually want it like this. This gives us information. Okay? Now, we remember from our linear equations part that if y is 0, okay, if y is 0, that's the x-intercepts, and if x is 0, that's the y-intercepts. Okay? So, if we say y is 0, we can find what's called the x-intercepts. Okay? But the x-intercepts, in other words, where it crosses the x-axis, that's the same thing as what we call roots. It's also the same thing as zeros. These are 3 vocabulary words that mean the same thing. Okay? So if I say find the roots of this equation, okay, you want to find the x-intercept, or where y equals 0. So what that really means, okay, is solve 0 equals x minus 2 and then x plus 4. Alright? Now hopefully you remember from our quadratic function, quadratic work before, that to solve something times something equals 0, you make the first something equal 0, or the second something equals 0. Remember this? So x is 2, or x is negative 4. Okay? So we can graph these 2 points. Let's go with x is 2, or x is negative 4. Okay? Those are our 2 points there. Now, it's a parabola, and it goes through these 2 points. These are the x-intercepts. These are the roots. Okay? We know because this is positive here, it's going to be smiley. So, whoops. So, it's going to be smiley like this. Okay? Somewhere along there. Okay? Now, we don't know that much more about it except to say that it's symmetrical. We know that it's a parabola, so it's symmetrical. So if it's symmetrical, that means the middle of these 2 points is the axis of symmetry. That's where the vertex is. So the middle of these 2 points, if I go over here 2, if I go over here 2, over 1, the middle is right here. It is, in fact, right there along x equals negative 1. Okay? So now, you see how I got that? That's the middle of these 2 roots. So if I plug in x equals negative 1 here, that's going to tell me where the vertex is. All right? Y equals negative 1 minus 2 times negative 1 plus 4. I'm just plugging in negative 1 for x here. All right? So that's the same thing as negative 3 times 3. So that's the same thing as negative 9. All right? So that means it goes through negative 1, comma, negative 9, right there. Now I can kind of see what the parabola is going to look like. Let's just double check. Let's plug in 0 here. X equals 0. That would be negative 2 times 4. That's negative 8, which means it goes through this point as well. And now I can see my parabola pretty well. Looks like that. I've drawn better, more symmetrical parabolas, but you get the idea, right? So we can find the roots and go from there, and then the middle number is where the vertex is going to be. Okay? So why don't you try one and then check to see if you can do it. Okay? We'll go down here to give you more room. Okay? Graph using roots. F of x, that means the same thing as y. Okay? X plus 5, x plus 1. Okay, so see if you can first find the roots. Go ahead and just find the roots of this. Okay? Okay, so you should have solved and gotten the roots, and you got x equals negative 5, x equals negative 1. So now we have our 2 roots. Okay, so go ahead and find the axis of symmetry in the middle of these 2 roots, a vertical axis of symmetry. Pause and do that now. Okay, and that is the axis of symmetry there. And the equation of this is just whatever this x value is, in this case negative 3, so it's just going to be x equals negative 3. That's the equation of the axis of symmetry. All right. Now, what we do is we find that this is negative 3. We plug this in. So I want you to find the vertex. Plug in negative 3 here to find where the vertex is here. Okay, good. So we plugged in negative 3, found that it was at negative 4. So now we have negative 3, negative 4, and from there I just did over 1, up 1, which matches our over 2, up 4. Okay? So I might as well just find one more point along here, what's called the y-intercept, by plugging in x equals 0. If I have x equals 0, or f of 0, that would be 0 plus 5 times 0 plus 1, so that's just going to be 5. So I put that there. I mirror it over the axis of symmetry there, and I have a beautiful parabola. Looks like that. Okay? Nice and easy. That's how we graph using roots. Now, of course, a lot of times it doesn't show in this way. What you have to do is you have to factor it first. Okay? So, if we were to factor it first, and hopefully remember how to factor quadratics, okay, if I said graph y equals x squared minus 3x minus 4, right? So what we would do is we would have to factor it and then find the roots. Okay? If you learn how to factor this, go ahead and try to factor this. Pause and go ahead and try to factor. So this is how I like to show factoring. I get to x minus 4, x plus 1. Okay, now if I'm finding the roots again, this is going to lead to x equals 4, and this is going to lead to x equals negative 1. So those are my two roots, negative 1 and 4. Now in this case, my middle is not an integer, because it's 1, 2, 3, 4, 5 spaces, so I have to go over 1, 2 and a half. It's actually right here. Okay, my vertex is a fraction. Yucky, oh no. These things happen. All right. I'm going to plug that in. That's 1.5, or 3 over 2. So if you plug in 3 over 2 to this, or to this, either one, and see what you get. Go ahead and do that now. Okay, so if you plug in 3 over 2, do some fancy fraction work, you end up getting negative 8 1/4. Okay, so 3 over 2, negative 8 1/4. You can also get, I don't understand why it does that. Okay, you can also, ask a calculator and do it that way, and that's fine. All right, one other thing I want to point out here is that this is the y-intercept. And the way it's super easy to find that out is that it's when x is 0 is the y-intercept. Well, so 0 squared is 0, minus 3 times 0 is 0. So it's just this part, okay? So whenever you have it in this format, this last constant is always the y-intercept, okay? So we can just pop that in, and at negative 4, that's right there, okay? And then reflect it over, and it's right there, okay? We could, if we want, plug in x equals 1 to figure out where along here it is. 1 squared is 1, minus 3 times 1 is negative 2, minus 4 is negative 6. So it's going to be right there, which means it's going to be right there. All right. Okay. Now, it should look like this. This seems a bit weird. I think it's right there. I think I messed up here. Did I mess up here? I bet I did. Because it should be about right there. I'll bet that it's negative 6. 4 goes into 25 6 times. Man, that's really, arithmetic. Anyhow, so it's right there, negative 6 1/4. That's wrong. I'm going to erase that. So it goes through right there. Okay, so that's graphing. We factor it first. We have our two roots, and then go from there. Okay, when this is odd, this b term is odd, the vertex goes through a fraction. So this got a little bit more complicated, but sometimes that happens. I hope you learned a thing or two, and we'll see you next time. Toodles.